learn more about a pinhole camera. What is a pinhole camera? Surely we need a lot of complicated stuff to make a camera. Not really. We just need to wish to make a simple pinhole camera. So when we think of a pinhole camera, you might be thinking we need so many things to make a camera. But here in activity 5, you will come to know that simple things you will be needed to make a pinhole camera. So let us look into the activity 5. So here we are asked to take two boxes so that one can slide into another with no gap in between them. Cut open one side of each box. So here we are asked to cut open each side of the box. On the opposite face of the larger box, make a small hole in the middle. So here we are taking the bigger box. This is the smaller box. In the bigger box, we are making a small hole in the middle of it. In the smaller box, cut out from the middle of the square with a side of about 5 to 6 centimeters. So the smaller box, we are cutting a square for about 5 to 6 centimeters. Cover this open square in the box with tracing paper, that is translucent paper. Slide the small. So here in this, when we have cut it out 5 to 6 centimeters, here we are sticking a translucent paper, that is a tracing paper. Okay. So what we are going to do next is slide the smaller box inside the larger box. So we are taking this small box and placing it inside this larger box. Inside, in this way, it should be going inside. So cover the opening square in the box as with the translucent and So slide the smaller box inside the larger one with the hole in such a way that the side with the tracing paper is inside. Your pinhole camera is ready to use. So when he's asking, the smaller one should be sliding inside the bigger one in such a way that it should be sliding inside out. You can move it in front or back. So this is your camera and this is ready. Let us see how we need to use it. Holding the pinhole camera, look through the open face of the smaller box. So here is the open face of it. We are going to look through this side. You should use a piece of black cloth to cover your head and the pinhole camera. So after you holding this pinhole camera, what you need to do is you need to take a black cloth and cover yourself and the camera into it. You have to put both your head and the pinhole camera inside that black cloth. Now try to look at some distant objects like a tree or a building through the pinhole camera. So you have to see a tree or a building from this camera. Make sure that the object you wish to look at through your pinhole camera are in bright sunlight. So don't use this one in the dark night, like right now in the darkness, but you need to use this pinhole camera where there is bright sunlight shining. Move the smaller box forward or backward till you get a picture on the tracing paper. So you need to adjust the small one until and unless you get a clear picture on this tracing paper. Tracing paper pasted at the other end. Are these pinhole images different from the shadows? So the shadows are different from these pinhole images. We are going to learn about that. Look through your pinhole camera at the vehicles and people moving on the road in bright sunlight. So you can use it from your balconies or in an open ground, and you can see whether the pinhole, when you're seeing an image from the pinhole camera, are the vehicles and the people moving on the road in the bright sunlight, are they looking the same as they look? We have to observe that. Do the pictures seen in the camera show the colors of the object on the other side? Are the images erect and upward side? Surprise, surprise. So here is asking, do the pictures seen in the camera in the color and the objects, can we see all the colors and the objects as they are, and the images are erect and standing straight and upward? This is the question. How it is, we are seeing like how we see in the mirror, are we able to see the same? This is the question. So let us see what we are able to see. Let us now image the sun with our pinhole camera. We need a slightly different setup for this. Now when you want to see a sun, here we need a different setup. We just need a large sheet of cardboard with a small pinhole in the middle. So here we are taking, now instead of taking this box, we are taking a larger cardboard. okay, with a small pinhole in the middle. The same way how we kept a pinhole here, we are going to take a larger cardboard box and we are going to put the same middle pinhole. Hold the sheet up in the sun and let its shadow fall on a clear area. Do you see a small circle image on this of the sun in the middle of the shadow of the cardboard sheet? So when you place this cardboard sheet with a pinhole in between, what you're going to see is a circle. What you're going to see is a clear circle. It's the shadow that falls in a clear area. So is the image of that is a small circular image, or which is on the middle of the cardboard paper? That is the question over here. Look at these pinhole images of the sun when an eclipse is visible from your location. So with this, we can use this pinhole image for the sun when an eclipse is visible. Whenever there is solar eclipse or lunar eclipse, you can use this pinhole camera. Adjust your pinhole and screen to get a clear image before the eclipse is to occur. So whenever you know that there is an eclipse, you can use this pinhole camera which we are going to make. Look at the image as the eclipse begins. So when you know that you will be given the timing when is the eclipse is going to begin, so at that moment you can use this pinhole camera to look at the sun or the moon. So you will notice a part of the sun's image gradually becoming darker as the eclipse starts. So whenever we know that there is a time, this is the time for the eclipse to begin, when you see through this pinhole, you can see the darker side of the darker image of the sun. So we should never ever look directly at the sun when there is an eclipse. That could be extremely harmful for your eyes. So here more there is what it is said is there is an interesting pinhole camera in nature. So here this is a man-made camera which we have made, and there are so many variety of cameras, and let us see which is a natural camera in nature. So sometimes when we pass under a tree covered with large number of leaves, we notice small patches of sunlight under it, like in this next figure. This is 11.6 figure. These circular images are in fact pinhole images of the sun. So here this is the shadow of this tree which you can see on the ground. You have seen this so many times on the road, and these patches which you can see, these are the pinholes of the sun. These are the nothing but the pinholes of the sun which you can see on the ground. These circular images are in fact pinhole images of the sun. The gaps between the leaves act as the pinholes. So these gaps are acting as the pinholes. These gaps are all irregular shape, but we can see circular images of the sun. Though they are irregular in shape, as you can see, here is big, it is small, here it is large, here it is small. So they are irregular in shape, but still we can see the circular images of the sun. You can see the circular images. When you stand in front of it, you can see some circular images of the sun. Try to locate images of the sun when an eclipse occur next. So here is asking us to try to locate some images when there is a next eclipse. That could be so much fun. Bujo has a thought. We saw upside down images of people on the road with our pinhole camera. So when you are using a pinhole camera, you won't be seeing the straight image. You will be seeing the reverted image, that is upside down images. So what about the images of the sun? Do we notice them to be upside down or anything like that? So he's asking, the Bojo is having a thought that if we are able to see the upside down images in the pinhole camera, then what about the sun? Are we going to see the sun also upside down through this pinhole cameras, is his doubt. So Paheli has another thought. Surely all these results that we are seeing, formation of shadows and pinhole images, are possibly only if light moves in a straight line. So when there is light is moving in a straight line, then only these images are formed. Then only we can see these shadows in the pinhole. So let us look into the next activity, that is the activity 6. So let us use a piece of pipe or a long rubber tube. So here in this activity, he's asked us to take a long piece of tube, rubber tube, or a piece of pipe. Light a candle and fix it on the table at one end of the room. Now, standing on the other end of the room, look at the candle through the pipe. So here is asking us to look through the pipe and fix this candle on the table and look through it in a straight line. Okay, it should be slanting. Is the candle visible? Bend. Is the candle visible is the question to us. So now he is asking us to bend the pipe a little while you are looking at the candle. When you are looking at the candle, he is asking us to slightly bend the pipe. Is the candle visible now? So do you think the candle will be visible if there is a slant like this? I don't think so. So in my opinion, in B image we cannot see the candle, whereas in the image A you can able to see the candle lit. So with this we can conclude that light travel through a straight line. So let us learn more so that you will come to this conclusion, you will understand in a better way. So here, is the candle visible now? Turn the pipe a little to your right or left. Can you see the candle now? No. If you move to a right or left also, you cannot see the candle. So what do you conclude from this? So your conclusions are being asked here. So this suggests that light travels through a straight line. As I have told you, the light is passing through a straight line, not in the curved line. So isn't it? That is why when an opaque object obstructs it, a shadow forms. So this is the reason why when there is an opaque object, it is obstructing an object. It is the reason why the shadow is formed, because the light is traveling in a straight line, not in a curved line. So let us look into the next topic, that is the mirrors and reflections. So we all use mirrors at home, isn't it? We all use the mirrors at home. You look into the mirror and see yourself, see your own face inside the mirror. What you see is a reflection of your face in the mirror. We also see reflection of other objects that are in front of the mirror. Sometimes we see reflection of trees, buildings and other objects in the water of the pond or a lake. So what do you see in the mirror? We see a reflection, isn't it? We see a reflection in the mirror. If we are holding anything in our hand, that also reflects in the mirror. And even in sometimes what happens when you go to a pond or a lake, we see a reflection of the tree which is in front of it. We can see the reflection of the building, anything which is in front of the water. We can opposite it. We can see the reflection of such objects. So let us look into the activity 7. This activity should be done at night or in a dark room. Ask one of your friends to hold a mirror in his or her hand at one corner of the room. Stand at another corner with a torch in your hand. So here again we are asked to do an activity in the dark room or at the night time, and here again we need few of your friends, and one of your friend we need to tell him to hold a mirror in his or her hand and stand in one corner of the room, and you should stand at another corner holding the torchlight. As here you can see in this image, one of the friend is holding a torchlight and one of the friend is holding the mirror and the other one is just standing. Yes, so let us see what happens. So what happens here is, stand at another corner with the torch in your hand, cover the glass of the torch with your finger and switch it on. So you need to cover the glass of a torch and with your fingers, and what you need to do is you need to switch it on. Now adjust your finger with a small gap between them so that you can get a beam of light. So you need to stop with your fingers. You have to keep your hand in front of the torch light and you should see that your fingers are allowing small beam of light to pass through it. So direct the beam of the torch light onto the mirror that your friend is holding. So you should hold in such a way that only a beam of light is falling in the mirror which your friend is holding. Do you see a patch of light on the other side? So you will be able to see the patch of that on the other side. Now adjust the direction of the torch so that the patch of light falls on another friend standing in the room. So you need to adjust in such a way that the patch of the light is falling on the other friend who is standing in the room. This activity suggests that a mirror changes the direction of the light that falls on it. So mirror, here with this activity we are coming to a conclusion that the mirror is changing the direction of the light that is falling on it. So you usually play such games, isn't it, in the bright sunlight in the schools. When you go to school in the bright sunlight, or whenever you're at home, if you have a small piece of mirror, you try to keep it in front of the sunlight and you play such tricks. So with this we are able to move the direction of the sunlight. Here in an activity that shows light travels along straight line and getting reflected from a mirror. So with this activity 7 we come to another conclusion, that the light is traveling in a straight line and also it is getting reflected from a mirror. So this is the last activity of the lesson, that is the activity 8. Here we are asked to fix a comb on one side of the large thermocol sheet and fix a mirror on the other side as shown in the figure 11.9. So here what we are doing, we are taking a thermocol and we are placing a comb on one side of the thermocol, and on the other side we are fixing the mirror. So spread a dark colored sheet of a paper between the mirror and the comb. So here what we are doing, in between the comb and the mirror we are placing a dark color sheet of paper on the thermocol. Then keep this in a sunlight or send a beam of light through it. Send a beam of light from a torch through the comb. So here we are using a torchlight which is passing from the comb and we are allowing it to pass through it. So let us see what are the observations. What do you observe? Do you get a pattern similar to that shown in the figure 11.9? This activity gives us an idea of a manner in which light travels and gets reflected from a mirror. With this we are able to see that the reflections are falling because of this mirror. So you can see the opposite here. You can see on the darker paper how the reflection of the comb is falling on the paper. So this is the activity 8 through which we can come to a conclusion with the same thing, that what is that idea we are getting, which is light travels and gets reflected from a mirror. So I hope you are clear with all this topic, that is which I have taught today, and I have covered every point. And if you like it, if you understand each point of it, so I would like you to subscribe this channel. I will make more of the videos of this subject, and I hope you like it. So please like, share and subscribe and comment. Thank you. Bye.